Alright, let's do this. Alright, so today is April 1st. So we're continuing on factoring trinomials. But whereas we worked with the term x squared plus bx plus c last week, this week we're working with the ones that say ax squared plus bx plus c. Remember, a, b, and c are just stand-ins for numbers. So we're going to be working with 3 numbers. So if you notice, the only difference between this week's and last week's so this is what we have this time. Our difference today is that we now have an A. So last week we just have x squared plus bx plus c, but now we're throwing an a in front of our x squared, and all this a is standing for is this just mean that there's a number in the very front of the trinomial that's not 1 or 0. If it was 1, you could still write it like this, but you could also write it like this. So all the ones that we did last week had a 1 in front of them. A was 1, so we write over here. All the ones in this week, we're not going to have a 1 or a 0 up there. It's going to be a different number. And the proper way to define this a and talk about it is that it's called the leading coefficient. So remember, a coefficient is a number in front of your variable. So a and b are both coefficients. A is called leading coefficient because it's at the very front. So remember, when we were in elementary school, the leader of the line would be whoever's at the very front of the line. So in this case, if you ever talk about the leading coefficient or something asks you what's the leading coefficient, it's the very front number, very first number in your trinomial. If your trinomial is in standard form. Alright, so some examples with this. Would be, so if we had 2x squared plus 5x plus 3. Note that 2x squared plus 5x plus 3 tells us alright. So with this, you're still going to do what we did last week. Draw a diagonal line starting at the 2, draw another diagonal line starting at the 3. Now, last week, every single time we did this, it was always just the number at the end because this was just 1. 1 times anything is itself. But this week, notice how our 2 lines intersect. They're touching the 2 and the 3, and then they intersect in the middle. So you do 2 times 3, which will give you 6, and bring down the 5. So now we need 2 numbers that multiply to give you 6 and add to give you 5. So looking at the factors of 6, we have 1 and 6, and 2 and 3. Since we are working with plus plus, that means our 2 answers are going to be 2 positive numbers. Same sign, so we're going to be adding. So if you added these and if you added these, this would give you 7, but this would give you 5. So you want the one that gave you 5. So it would be 2 and it would be 3. So then once you have those, you go off to the side and draw you a box. Now with this box in this top left corner, put the first term of the trinomial. In this bottom right corner, the last term of the trinomial, which is a positive 3. And in these 2 corners, you're going to put the 2 numbers that you just found. So 3x and 2x. And you have to throw an x in front of them. So if you remembered from the box method, this was the, this is going to go looking diagonally with exponents. Exponents are the small numbers up top of 2, 1, 0, because these both have a 1. Alright, now looking at the left column, since they're both 2, we're going to pull out the greatest common factor. So we're going to do the greatest common factor with the numbers of 2 is 2. Now there's an x in both of them. This one has an x squared, this one has an x to the first. You always take the smaller variable, so you can factor out an x to the first. So you could factor out a 2x out of this column. In this column, 3 goes into 3, so you can factor out a 3, but only one of these terms has an x, the other one does not, because it is a constant. Alright, so looking at this top row, 2 does not go into 3, but 1 goes into 3, and then x squared and a positive x to the 1, so factor out an x to the 1. This last term, 2 doesn't go into 3, they both don't have x's, but when that happens, you always have a default greatest common factor, which is a positive 1, because 1 goes into every single number. Well, then your answer, your factored form of this, would be what you got here. Vertically, we got x plus 1, and horizontally, we got 2x plus 3. And note that since we wrote plus plus to the side, in our answer, in our factored form, our two answers were positive. Remember, and if you're unsure of your answer, if we were given the simplified trinomial and factored it, and taking the factored form, you can simplify it, and when you simplify it, you should get back to that original trinomial. Alright, this one is number 4. It is 12c squared plus 11c minus 5. Okay, again, looking at the constant, the sign in front of the constant is negative, and the only way you're going to get a negative out of multiplication is if one of those was positive and one of them was negative. Again, drawing our two lines. Negative 5 times a positive 12 will give you a negative 60, and we have a positive 11. Now then, notice this plus minus. That means one of these numbers is going to be a positive and one of these numbers is going to be a negative. Because we need these two numbers to multiply and give you a negative, which you're only going to have if one of them is negative, one of them is positive. And when you combine them, you need a positive number. That means you're going to be taking the difference. So looking at the factors of 60, we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9 do not go in there. They don't go into 16. Alright, since one of them is positive, one of them is negative, and we end up with a positive number, that means it's going to be the bigger number. The only way you're going to get a positive number out of subtraction is if your bigger number was positive and your smaller number is negative. So if you did 60 minus 1, you'd get 59. You would get 28 here. You would get 17 here. You're going to get 11 here. You're going to get 7 here. And you're going to get 4 here. We want the 11 though, because R is 11. And that only comes if you have a positive 15 minus 4. Okay. Again, go off to the side, draw your box. In this top left corner, we're going to put 12c squared. In this bottom right corner, we're going to put negative 5. And in the middle, it doesn't matter what order you put in this one I put the 2 in the bottom left corner and the 3 in the top right, so I'm going to switch it up. I'll put the negative 4 in the bottom left corner. Don't forget to attach a C on there. and I'll put the positive 15c in the top right corner. Only these two can be interchangeable. This one has to have the squared value. This one has to have just the constant. Alright. So, your first thing to do is look at, when you're looking for a factor, a greatest common factor between these two, ask yourself, does the smaller number go into the bigger number? In this case, does 4 go into 12? If your answer is yes, then that's your number. That's going to be part of your greatest common factor between these two. And they both have a c to the 1 in them. Alright, so another thing I need to touch up on is notice how this one was positive, but this one was negative, and we came out with a positive. We came out with a positive because the numbers that you factor out, so this number is touching this box. This box is positive, so we got to come out with positive. Again here, since 15c is positive, this is going to be a positive. Ask yourself again, does 5 go into 15? If your answer is yes, then go with 15. Then go with 5. This has a C, and this one does not have a C. Going sideways, 12 is smaller than 15. Does 12 go into 15? No? Okay. If you need to, you can look at the factors of 12. Always look at the factors of the smaller number. 1 and 12, 2 and 6, 3 and 4, and that's it. Alright, so since 12 didn't go in there, go to the next biggest factor of 12, 6. But 6 doesn't go into 15 either, so then go to the next biggest one, which would be 4. 4 does not go into 15, so go to the next biggest one, which is 3. And 3 goes into 15, and since it was a factor of 12, then we know 3 goes into 12 and 3 goes into 15. So that's it. Again, you can see that there's a c to the 1 in both of these. So we can factor out a c to the 1. Alright, on this last one, since we're going to write our answer to the left of this box, and this box is negative, our answer is going to be negative. Does 4 go into 5? No. The factors of 4 is 1, 2, and 4. 2 does not go into 5, but 1, again, does. And since they're both negative, you can factor out a negative 1. And again, since this box is negative, what you're factoring out next to it has to be negative. This box is positive, so the two numbers next to it touching the box are positive. This was positive, so this one has to be positive. And if you're unsure, we'll multiply. What's 4c times 3c will give you 12c squared. 5 times a 3c gives you 15c. A positive 4c times a negative 1 gives you a negative 4c, and a positive 5 times a negative 1 gives you a negative 5. If you can multiply these two numbers touching each box and get what's inside, then you know you factored correctly. Alright, again, your answer is going to be this vertical one, which in this case it's 3c minus 1, and this horizontal one, which is 4c plus 5. Alright. Okay. Alright, now these, in your notes, it stopped saying examples, and this section is called the You Try section. Alright, and this is number 1 in that section. It is 3y squared minus 11x plus 10. Okay. Notice that this one is a positive at the end. So the only way that you're going to get a positive in multiplication is if your two numbers were already positive, or if your two numbers were negative. Because two negatives give you a positive, two positives give you a positive. You know which one it is by looking at this middle term. Since this middle term is subtraction, then we're working with two negative numbers. Whereas in this one up here, we did have positive, but this middle term was positive, so that told us we were in positives. Again, draw your box. 10 times 3 will give you a 30. And then negative 11. Since these two are both negative, that means in here is going to be negative 2. Alright, so the factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4, 5, and 6. Now then, since these two are the same side, that means you're going to become adding the terms and keeping the sign. So let's see which one gives us 11. This gives you 31. This gives you 17. This gives you 13. This one gives you 11. So the one that gives you that 11, that's your term. 5 and 6. Now negative 5 times negative 6 gives you a positive 30, but negative 5 minus 6 gives you a negative 11. Again, I'm just drawing my box. Your square term goes in this first one. Your constant goes in this last one. And then you just have to throw in the two terms that you find, the two terms you just found in one of these two boxes, the other one in the other one, and then throw one of the variables behind it, so both of these have a y. So looking at up and down, since this box is positive, these both are going to be positive. 3 doesn't go into 5. And since 3 is prime, the only numbers that go into 3 is 1 in itself. So since 3 doesn't go into 5, then it's going to have to be 1. They both have a y to the 1, so we can factor that out. Since this box right here is negative, that means this is going to be a negative. 6 doesn't go into 10. So then the next biggest factor of 6 would be 3. But 3 doesn't go into 10 either. So then we look at 2, and 2 goes into 6, and 2 goes into 10. There's only a y in one of these, so we can't factor out a y in both. Remember, to factor something out, it has to be in both of them. Alright, looking sideways. Since this box was positive, this factor will be positive. So 3 is a smaller number. 3 does go into 6. It goes in it twice, so you can factor out a 3. There is a y to the 1 in both of these terms, so you can factor out a y to the 1. Since this term was negative, this factor will be negative. 5 is smaller, so 5, you ask yourself, does 5 go into 10? If your answer is yes, then that's your factor. Since this has a y and this does not, that is it. So when you're writing your factor, you could actually write the vertical one first, or the horizontal one first. So this would be y minus 2. And then write the horizontal one, which is 3y minus 5. It doesn't, to me, I'm not as picky about the order of them as more of you guys getting this method down. Later on we can fix the order of it, but I really want you guys just to make sure you have the right sign in front of the right number. My priority is making sure you guys have the right signs, have the right numbers, and have it all factored correctly. That is my priority right now. Later on we can talk about which order should be the correct way to write them. But you gotta get the steps done first. Alright, so we've done a plus plus, we've done a plus minus, we've done a minus plus. So that leaves us with a minus minus example, which we will just see. Alright, so this is 10p squared minus p minus 2. My cat's getting into trouble again in this house. Okay. So again, look at this look at your constant, the sign in front of it. The only way you're going to get a negative out of multiplication is if one of those numbers was positive and one of those numbers was negative. Then looking at the middle term, this tells you that the bigger number is the negative number. Alright. So this just tells you the signs. This tells you which number is going to be bigger, but in this case it's the bigger number. So then again, draw your two lines. 10 times a negative 2 is negative 20. And then remember, there's always, if it's just negative p, there's a 1 right there, so that would be negative 1. And one of these numbers is positive and the other one is negative. So looking at the factors of 20, 1 always goes into 20 times. Then 2 would go in there 10 times. 3 does not go into 20. 4 goes in there 5 times, and that's it, because then it'd be 5 times 4 and that repeats. So, alright. Since we said that the bigger number is negative, I could actually just subtract straight across. This would give you negative 1, this would give you negative 8, this would give you negative 19. Then from here, the one that gave you this middle term that you're looking for is the two numbers you want. So notice our 5 was behind the subtraction sign and our 4 was in front. So this correlates with this. We said the bigger number has to be negative, and our bigger number is negative. Going off to the side, I'm going to draw my box. You don't have to draw your box as big as I like to draw mine. You can draw them smaller. Sometimes I just like to draw mine big so I can see the numbers because I don't have the best vision. Alright, so we're going to put 10p squared here. We're going to put negative 2 right here. Then I'm going to put negative 5p here. And a positive 4p here. Alright, so does 4 go into 10? No, it does not. So then go to the next biggest factor of 4, which would be 2. Does 2 go into 10? Yes. Alright. There's a p to the 1 in both of these, so you would factor out a p. You could put a little 1 up there. Now since this box is negative, we know this is going to be negative. Does 2 go into 5? No. The next biggest factor of 2 would be 1. Does 1 go into 5? Yes. 1 goes into every single number. Only one of these has a p, the other one does not, so that's it. Going horizontally, 5 is a smaller number. Does 5 go into 10? Yes. If your answer is yes, you write that number down. The smaller one, 5. Since 10 is positive, the two numbers touching it, the two factors touching it, should be positive. Okay, they both have a p to the 1, so you can factor out p to the 1. Now looking at this bottom left corner and this bottom right corner, 2 is smaller than 4. Does 2 go into 4? Yes, it does. So you can factor out a 2. Since this 4 is positive, that means this factor has to be positive. So then when writing your answer, I like to write the vertical one first. You can write the horizontal one first. Remember, multiplication is commutative. So this gave you 5p plus 2 because this is a positive 2. If it was a negative, it would have a negative. And 2p minus 1. If you're unsure if that's truly the answer, you can always FOIL this or do the box method and simplify it. And when you simplify it, you should get back to where you started. Alright. Doing another example. We have 4a squared minus 4a plus 1. Again, we have that minus plus again. The only way we're going to get a plus is either two positives or two negatives multiplied against each other. But since this middle one is negative, that tells us we're working with a minus minus. 4 times 4 is 4. 4 times 1 is 4. And then we have a negative 4. Factors of 4 is 1 in itself and 2 and 2. I always draw that line, by the way, to tell myself that's the end of the factors. Okay, since they're the same sign, you can just go ahead and add these. Because same sign, remember, if you have, whether it's a negative minus a if it's a number minus, a negative minus a number, or a positive plus a number, if the signs are the same when doing subtraction or combining, if the signs are the same when you're combining two terms, two like terms, then you add the numbers together and keep the sign. So adding these numbers together, this will give you 5, this will give you 4. We want one that's going to give you a 4. And since these were both negative right here, this is actually going to be a negative. A negative And then 4 would be 2 and 2. Okay, so going off to our side to draw our box. Whoops. I didn't even notice I was going off the paper. Okay, 4a squared up here, a 1 here, a minus 2a here, and a minus 2a here. In this case, it didn't matter which one we put in there because they were both negative 2. Alright, looking at this. Does 2 go into 4? Yes, it does. So that's a 2 right here. We have an a to the 1 in both terms, so factor that out. Okay, since this top right box is negative, that means our factor is going to be negative. Does 1 go into 2? Yes, it does. And then there's not an a in both terms. So going horizontally, again, since this is a positive box, the two factors touching it, it's going to be positive. Does 2 go into 4? Yes, it does. There's an a to the 1 in both terms, so you can factor that out. Then in this bottom row, this bottom left box is negative, so your factor is going to be negative. Does 1 go into 2? Yes. So then that would be 2a minus 1 times 2a minus 1. Notice that the same thing multiplied against each other, so when you write out your factors and it's something times itself, then the correct way to write that would be 2a minus 1 squared. So remember, when you square something, you're multiplying that quantity times itself. Alright. Again, we have to look at some that have a greatest common factor. So if we're looking at number 7, it's 10k squared plus 75k plus 35. Alright. Notice, yes, you could just go ahead and straight up do it this way, but 10 times 35 would be 350, and I really don't think you want to be trying to find all the factors of 350. So in your homework, it's going to have a section literally split off that says with a greatest common factor. So what you got to do, once you have a number, once you have an a squared, a leading coefficient, we started off with just, all of these did not have a greatest common factor, but these do. So look at your leading coefficient. Does 10 go into 75? No, it does not. So then the next biggest factor of 10 would be 5. Does 5 go into 75? Yes. Does 5 go into 35? Yes. Alright, so then go ahead and factor out a 5. Remember, when you factor out something, you're taking that original term, 10k squared, and dividing it by your greatest common factor. In this case, it was 5. Since it's just a number, then you just do 10 divided by 5, which would give you 2. Bring down the k squared, bring down the plus. 75 divided by 5, that would give you 15. Bring down the k. And then 35 divided by 5 would give you a 7. I don't know about you, but I would honestly rather be finding the factors of 14 than be finding the factors of 350. Alright, so once you have it here, you do the same exact methods. 7 times 2 gives you 14, and you're trying to add up to be 15. We're at a plus plus, so that means our answers are going to be plus plus. Alright, the only way you're going to multiply to get 14 and add to get 15 is 14 times 1. Because 14, you have 1 and 14, and you can have 2 and 7, and that's it. This would give you 15, and then this one would only give you 9. And we want the 15. So setting up your box again, in the top left corner we have 10k squared. In the bottom right corner we have 35. Then I'm going to write 14k here, and then 1k here. Alright, so looking up and down. Does 10 go into 14? No, it doesn't. Okay, so the next biggest factors of 10 would be 5. Simple thing, 5 only goes into numbers that either end with 5 or end with 0. 14 is neither, so it won't go in there. So then we look at 2. Since these are both even numbers, 2 automatically does. 2 is always a factor of an even number. Alright, they both have a k to the 1 in them. Over here, does 1 go into 35? Yes, it does. Looking horizontally, does 1 go into 10? Yes, it does. We have a k to the 1 in both spots. I wrote that a little bit too low. Give me a second. Alright, looking across here. Does 14 go into 35? No, it does not. Oh my gosh. You're not supposed to write 35 here. You don't write this original one. You write this first one, 7. Yeah, you're right. Because we're looking at this trinomial now. Not this one. This is what we started with, and then we modified it, so we're looking at 7. Does 7 go into 14? Yes, it does. This would still be a 1 because 1 does go into 7. Alright, so then this would give you... I'm going to write the horizontal one first, 2k plus 1 times k plus 7. Also, remember that since she factored out this 5, it doesn't go away, it just gets dragged along in the front. I'm going to do another example because I kind of messed that one up. This is number 8. It says 12x squared plus 2x minus 2. So again, notice that since they're all even numbers, you can factor out a 2. And make sure your variables go 2, 1, 0. When we're working with the trinomial and factoring, you want 2, 1, 0. Alright, 12 divided by 2 would give you 6x squared. 2 divided by 2 would give you 1. 2 divided by 2 would give you 1. So bringing down those original signs. Alright, 6 times a negative 1 is a negative 6, and this is a positive 1. So you want two numbers to multiply to give you negative 6, and add to give you positive 1. Remember, the only way you're going to get a negative out of this is if one of them was a positive and one of them was a negative. So again, and since this middle number is positive, that means the bigger number was positive. So the factors of 6 are 1 and 6 and 2 and 3. Since they're going to be opposite signs, that means they're going to subtract each other. So the difference of 6 and 1 is 5, and the difference of 3 and 2 is 1. So that's the one we want. And since this is positive, that means the bigger number is positive. So we would put the 3 here and the 2 here. Then drawing our box. We would put the first term in our new modified one, 6x squared, in the top left. We would put the last term in our modified one in the right, and then we would put negative 2. Remember to throw on an x attached to that, and a positive 3x. Alright, so then does 3 go into 6? If your answer is yes, you write that 3 down, and there's an x to the 1 in both of these, so you can factor that out. Since this is negative, this is going to be negative. Does 1 go into 2? Yes. Alright, going this way. Does 2 go into 6? Yes. And they both have an x to the 1 in them. And so you can factor that out. Does 1 go into 3? Yes. Notice since 3 was positive, this factor is positive. Since 2 is negative, this factor was negative. So then writing that out, you would have 2x plus 1 times 3x minus 1. And if you want to double check that, you could always check it out. Remember to keep your 2 at the very front. Because these are technically, it's a quadratic, because the highest order of this is 2. So it is a quadratic, but since there's no equal sign anywhere, it's going to be an expression, and numbers just don't go away in expressions. You can factor them out. They're just going to be sitting out. They're sitting ducks. They're just going to chill out here until you decide. The only way they're going to go back into your problem is if you distribute it back in. Which we will not be in this case because this is the correct way. Alright. If you have any questions, let me know.